The subject is DBMS Database Management System and subject code is AL502. In this session, I will discuss an important topic, relational data models, which explain how data is organized or stored and related inside a database system. Understanding this concept is essential for anyone working with databases. So let's begin the session on relational data models. Now let's understand what the relational model is. The relational model organizes the data using tables, also known as relations, which consist of rows and columns. It basically defines how data is stored and managed in a relational database. In this model, data is organized into different tables and each table is called a relation. Each row in the table represents a record or entity, and every column represents a specific attribute of that entity. These structures are used in popular RDS relational database systems such as MySQL and Oracle SQL. Now let now let's discuss the key components and characteristics of the relational model. The first component is relation. A relation is simply a two-dimensional table that stores a collection of data elements. It has rows and columns where rows represent entities and columns represent their attributes. Next we have a tuple. A tuple refers to a single row in the relation. It represents one record or one instance of an entity, and each tuple contains a set of attribute values and describing the specific entity. Then comes the attribute. Attribute is name column in a table. It shows a specific property or characteristics of an entity. For example, in a student relation, the attribute could be student ID, student name, and student address. Finally, we have the domain. A domain defines the set of possible values that an attribute can have. It also specifies the data type and permissible range for that attribute. For example, the domain for an age attribute might include only positive integers. So these four components form the foundation of the relational model. Now let's understand the characteristics of the relational model. These characteristics defines how data should be stored and maintained in a relational database. The first one is atomic value. Each cell in a relation must contain only single value. It cannot store multiple or nested values. For example, a student hobbies column should not contain multiple hobbies in one cell. Each value must be atomic. Next we have unique rows or unique rows or tuples. Every row in a table must be unique. No two rows can be exactly the same. This is usually ensured by using a primary key. Then comes to the column homogeneity. All the values in a column must be of the same data type and belong to the same domain. For instance, if a column is defined for age, it should contain only numeric value, not text. The next two characters deals with order. The order of columns in a table does not matter. Changing it does not affect the meaning of the data. And finally, unique column name. Each column in a table must have distinct name and there is no confusion when accessing or referencing data. So now let's move to another very important concept is the relational model, which is keys. Keys are the fundamental components that help ensure data integrity, uniqueness, and efficient data access in the database. In simple terms, a key is used to uniquely identify each row, or what we call a tuple in a table. Let's understand why we actually need keys in DBMS. The first reason is uniqueness. Keys make sure that every record in a table is unique and cannot be identified separately. For example, a student ID in a student table ensures that no two students have the same ID. The second reason is data integrity. Keys prevent data duplication and help maintain the accuracy and consistency of data. Without keys, duplicate or inconsistent data could easily appear in our tables. And third reason is efficient data retrieval. The keys help us link tables together and make searching or querying the data much faster. Without them, managing large data set would be very difficult and queries would become slow. So keys are essential in DBMS because they keep our data unique, accurate and easy to access. Now let's understand some important concepts. The first one is relational database. Relation database is simply a collection of related relations, and or in simple words we can say collection of tables that are connected to each other through relationships. It all helps to ensure data integrity, maintains relationship among different entities. For example, in a college database, we might have tables like a student, department, and codes all linked together through keys. Next, we have schemas, and schemas defines the structure of the database. It tells us what table exists, what attributes they have, and how they are related. In other words, it is like a blueprint of the database. And for example, we can define a schema as a student table. In a student table, student ID, student name, age, codes, and a department ID. Here's the schema tells us that the student table has five attributes. Now let's talk about the integrity constraints. These are the rules applied to maintain the accuracy and consistency of data in the database. They ensure that the stored data always remain valid and meaningful. One very important type of constraints is referential integrity. These rules state that a foreign key in one table must match a valid primary key in another table, or maybe it will be null. For example, if a student department ID refers to a department and the department ID must already exist in the department table, if it does not, it would violate referential integrity. Finally, let's understand intension and extension. Intension refers to the definition or structure of a relation, basically the schema, whereas extension refers to the actual data present in the relation at a particular time. So we can say intention describes what the tables look like and extension describe what the table currently contains. So basically, relational database is a collection of related tables, and a schema defines a structure, and integrity constraints maintain its correctness, and referential integrity ensures valid relationships, and intention extension describes the structure and the actual data respectively. So now let's talk about SQL. SQL is a standard programming language that is used to manage, manipulate, and query data in a relational database. In simple words, we want to create a table, insert data, update it, and or fetch some specific information from the database. So I use SQL commands. These SQL commands are basically instructions that helps us to define the structure of the database, manipulate data, and control access to the data. All SQL commands are grouped into five main categories, which are DDL, TQL, DML, TCL, and TCL, each serving a specific purpose in managing relational database. Let's go through them one by one. So first one is DDL, data definition language. Commands are used to define and modify the structure of database objects like table, indexes, and schemas. These commands are also allow us to create new tables, alter existing ones, removing them, and shaping the overall database structures. Let's look at some of the key DDL commands used to define and manage database structures. The, the first one is create. Create command is used to create new database and its objects, and drop, as the name suggests, drop deletes database object completely. And next is alter is used to modify the structure of existing database objects. And the truncate commands remove all the records from the table but keeps the table structure. Comment also used to add descriptive notes or comments to the data dictionary about the table or column, which can be useful for documentation. And rename, finally rename let you change the name of the existing database objects like table or column. Next is DQL. DQL is used to retrieve data from the database. With these commands, we can query the data we need, filter it, sort it, and aggregate it. Essentially, DQL let us ask the database question and get meaningful results. And the DQL commands is first one is the select, and this select is used to choose the columns of data you want to see, and next is from. This tells the database which table to fetch the data from. And where, the where pulse is used to filter rows based on a specific conditions. Group by allows us to group rows that have the same values in certain columns, often use aggregate functions like sum, average, max, minimum, and count. And next is having. While where filters rows before grouping, having filters the result after grouping. Distance is distance. Next is distance. This remove duplicate rows from the result set, showing only unique records. Order by, this sorts the output by one or more columns, either in ascending or descending order. Limit restricts the number of rows written and which is useful when working with large data sets. Next is DML. DML commands are used to manipulate data within the tables. These include adding new records, updating existing records, deleting records. DML is all about managing the data that lives inside the database. DML commands are insert. This command is used to add new records to a table, and update is let us modify existing records in a table, and delete is this command is used to remove records from a table. And next is DCL. DCL commands control access and permission within the database. This allows us to grant and revoke rights to user, ensuring that only authorized people can perform certain actions. Now let's move to the DCL commands. First one is grant. Grant is gives a user specific privileges, allowing them to access or perform certain actions on database objects like table, views, or functions. Revoke has the same has the name suggests. Revoke removes previously granted privileges. In short, the grant and revoke help us to control who can do what in a database, ensuring security and proper access management. Next is TCL. TCL commands manages transactions which are groups of database operation executed in a single unit. They ensure data integrity by allowing us to commit useful successful transactions or rollback changes if something goes wrong. TCL commands is begin transaction. This command is start a new transaction, grouping a set of operation into a single unit that can be executed together. And commit. Commit save all the changes made during the transaction permanently in the database. Rollback, undo all changes made in the current transaction, which is useful if something goes wrong. And next is save point. Save point allows you to mark a specific point within a transaction so you can roll back to that point without doing the entire transaction. Next is integrity constraints. Integrity constraints are rules in a DBMS that ensure data remains accurate, consistent, and reliable. Think of them as guidelines that make sure all information in the database follows a specific standards. In DBMS, integrity constraints ensure data In DBMS, integrity constraints ensure data is valid and reliable. These are two main types: domain constraint, entity integrity constraints. Domain constraints makes sure column values are valid within a specific range, for example, not null and check. Next is integrity constraints. This ensures that the primary key is unique and never null, so every row can be uniquely identified. Key constraints in DBM ensure certain columns uniquely identify each row, maintaining data integrity and preventing duplicate. Primary key must first one is primary key. Primary key must be unique and not null, ensuring every row identifiable, and unique key ensures value are distinct and preventing duplicates but allows one null value. These constraints also help to maintain relationships between tables and enforce reliable data. Referential integrity constraints ensure relationship between tables remain consistent. A foreign key must match a primary key in another table or be null, preventing records and maintaining logical links. Assertions are global rules that ensure specific conditions are always true across the database, applying to multiple tables. Triggers. Triggers are triggers are automatic actions executed in response to events like insert, update, or delete, used to enforce complex rules or business logic that standard constraints cannot handle. Next is join. The topic is join. Join in SQL combines data from two or more tables based on a related column, usually a primary key and foreign key relationships. Uh, it helps retrieve information that a single table cannot provide. There are four main types of joins. Is first one is inner join, left join, right join, full outer join. Inner join. First is inner join. Inner join returns only the rows that have matching values in both tables. Any non-matching rows are where executed. And the second is returns or left join. It returns all rows from the left table and matching rows from the right table. If there is no match in the right table, the result shows null for its columns. The next is right join. Right join returns all rows from the right table and the matching rows from the left table. If there is no match in the left table, the result shows null for its column. Next is full outer join. Full outer join returns all rows from both the table. If there is no match, the missing side shows null. Not all database support it directly. In MySQL, we use combination of left join and right join with union. The next topic is relational algebra. Relational algebra is a procedural language that uses operators to retrieve data from tables. Each operation takes one or more tables as input and returns a new table as output. It is based on set theory and logic. Main operation is select and project. Select chooses the rows that meet a condition. Project chooses a specific columns from a table. Next is join. Join in a relational algebra combines related rows from two tables based on a common attribute. And types of joins is theta join, equijoin, and natural join. Next is division. Division is used to find rows in one table that are related to all rows in another table. Example, a student course and B is course and then A divided by B list students who have all courses in B. Outer join combines two tables even if they have different columns. Missing attributes are filled with null. Relational calculus. Relational calculus defines that non-procedural language specifies what to retrieve, not how, based on predict. The purpose is provide a declarative way to describe query results. The types as tuple-oriented relational calculus and domain-oriented relational calculus. Object-oriented relational calculus uses tuple variables representing rows, and domain-oriented calculus is uses domain variables representing column values. Key points is TRC deals with tuples and DRC deals with attributes and columns. Thank you.